Your smartphone seen through the eyes, ears, brain genius of Einstein. Why does human observation matter? Our premise is that we have a new civilization based on these smartphones. If Einstein were investigating nature today, he would start with what he finds inside your smartphone. Smartphones are now the defining feature of our civilization and need to become the defining feature of our science. We have been exploring what's inside your smartphone. We've been exploring it with Einstein, and we stumbled upon the idea that quantum mechanics is needed to explain almost everything in your smartphone. We discovered that in order to understand the memory inside your smartphone, we have to understand quantum tunneling, and it turns out that almost everything about your smartphone requires quantum mechanics for us to understand it. We must therefore address the Achilles heel or fatal flaw of quantum mechanics, which is the question, why should human observation be the defining feature of our science when human observation matters so little and usually does not matter at all to nature itself? David Mermin, a professor of quantum mechanics at Cornell University, said, "Quantum mechanics has proved that the moon only exists when people look at it." Consider Schrödinger's cat. Schrödinger's cat is a thought experiment, not a real cat, not a real experiment. The idea is that we take a cat and we put it in a box for 1 hour. Now inside that box, there is a mechanism that will at random release cyanide gas and kill the cat. So over the course of 1 hour, there's a 50-50 chance of the cat being killed by the cyanide or not. And until we open the box and look, we don't know which has happened. During that hour, when the cat's in the box and we don't know whether it's dead or alive, quantum mechanics says that the cat is in a state of being completely, fully dead. And at the same time, fully, completely alive. The same cat is in both conditions, both states simultaneously. This is called a superposition of states. Now, when we open the lid and look, bang! One of those possibilities vanishes, the other one becomes reality. So the idea is, it's insane. The idea is that reality only comes into existence when we view something, when we look at it or measure it. Believe it or not, Einstein asked the quantum experts, would the observation of a mouse instead of a human cause the wave function collapse? If it were not a human opening the lid to look, but a mouse, would that cause the same phenomena? And guess what? No one could figure out an answer. Why should our science depend on the observation of humans or mice when nature has existed across 14 billion years and billions of galaxies without the observation of either mice or humans? The answer to that is going to turn out to be because of the doctrine of wave-particle duality. Now, what does that mean? In 1909 and again in 1911, Einstein said, before anyone else said it, he said that in the quantum world you have something which, looked at from one perspective, appears to be a particle, and looked at in another way appears to be a wave, and yet these are two aspects of the same thing. That idea is called wave-particle duality, and it became central to quantum mechanics. We claim that is dead wrong. Now, how can this be dead wrong? The alternative is a theory of elementary waves, TEW, which was invented by my cousin Louis E. Little.
Greetings, I'm Louis Little. Jeff Boyd has done a marvelous job here of presenting the elementary wave explanation of the quantum eraser experiment, and I want to thank you for your interest.
In the quantum world, you have a particle following a zero energy elementary wave backwards. So the particle carries all the mass and energy and momentum, and it follows backwards the elementary wave. Now you may say, as most people do, that TEW is so preposterous that I'm just going to throw it away. I'm not even going to listen to this nonsense. But here's the problem. You have a choice. You have to either accept Schrödinger's cat as sensible, or you have to accept TEW as sensible. There's no third choice. You've got to accept one preposterous idea or the other preposterous idea. In TEW, we say that waves and particles are different, and therefore wave function collapse occurs when a particle and wave connect with each other, and then at a later point we can observe the particle and see what had happened at an earlier point. For example, the TEW perspective on Schrödinger's cat is that the cat died or did not die when it breathed in cyanide, and then only at a later point did humans come to understand what had happened at an earlier time. End of our discussion of human observation. If you like it, press the like button below, subscribe, and expect soon to see the next chapter in this playlist.